Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into the nature of time, a concept so familiar that we rarely question it, and yet so mysterious that even physics has not fully untangled it. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a gentle reminder of how many different moments are unfolding across the world at once. Now feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's begin. Take a moment and think about time. Not the kind you measure on a clock, but the kind you feel. Perhaps you've noticed something strange about it. When you were younger, time seemed to stretch endlessly. Summers felt like entire lifetimes. A single year carried weight, texture, and a sense of vastness, as if each day was something to be explored slowly. But as life moves forward, something shifts. Years begin to fold into one another, weeks pass quietly, and sometimes you look back and wonder how entire chapters of your life seem to slip by, almost unnoticed. It can feel as though time itself has changed speed. And yet, if you were to place a clock beside you, you would see something very different. The seconds tick by at the same steady rhythm. The minutes do not rush. The hours do not stretch or shrink. The clock remains calm, indifferent, and precise. So there's already a quiet contradiction here. The time you feel and the time that is measured are not the same, and this difference becomes even more noticeable in the small moments. Imagine sitting in a waiting room, perhaps at a dentist's office. There's nothing to distract you, no phone, no conversation, no movement, just a quiet room and the slow passing of seconds. In that space, time can feel almost heavy. Each minute lingers, each second seems to echo. You might glance at the clock, expecting a noticeable change, only to find that barely any time has passed at all. Now compare that to a different moment. You're with friends. You're talking, laughing, sharing stories. There's a gentle rhythm of conversation, a flow of attention from one moment to the next, and suddenly, an hour has passed. It didn't feel like an hour. It felt like something much shorter, something lighter. So in one situation, time stretches, in another it collapses, but the clock never changes. This raises a simple but deeply unsettling question. If time itself were truly flowing, truly speeding up or slowing down, then wouldn't the clock reflect that? And if it doesn't, then perhaps the flow we experience is not something happening in time itself, but something happening within us. It's possible that what we call the passage of time is actually the passage of experience. When your mind is engaged, when you are learning, reacting, feeling, and absorbing new moments, your attention is filled, and in that fullness, time seems to slip by unnoticed. But when your mind is quiet, when there is little to hold on to, each second becomes visible. Each moment stretches into awareness. Time hasn't changed, but your relationship to it has. And this idea becomes even more intriguing when we think about memory. Think back to your childhood again. Those long summers, those endless days. They weren't just long in the moment, they also seem long in memory. Why is that? One possibility is that when you are young, nearly everything is new. Your brain is constantly recording, building, storing fresh experiences. Each day adds something distinct to your memory. But as you grow older, many experiences become familiar. days begin to repeat patterns, fewer new memories are formed, and so when you look back, that period feels compressed. Not because it was shorter, but because less was recorded. So in a quiet way, time may not be something we simply move through. It may be something we construct, moment by moment, through attention, memory and change. And yet, despite all of this, there remains a powerful feeling that time is flowing, that there is a past behind us, a future ahead, and a present moment that we're somehow moving through. It feels almost like standing in a river. The future flows toward you, becomes the present, and then slips into the past, carried away behind you. It's such a natural image, so intuitive, and yet, what if that river doesn't exist? What if nothing is actually flowing at all? What if the feeling of movement, the sense that time is passing, is something created by the way our minds experience change? It's a strange thought, but it's one that physicists have been quietly considering for a long time, because when they write down the equations that describe the universe, when they carefully map out how things move, interact and evolve, they don't find a flowing river. They find something much simpler. Time appears, not as a force, not as a current, but as a number, a coordinate, a way of labeling change rather than causing it. And this leads us toward a deeper question. If the universe itself does not contain a flowing time, then where does our experience of time come from? Why does it feel so real? Why does it seem to carry us forward, moment by moment, without pause? As we continue this journey, we'll begin to gently peel back the layers of this idea. We'll see how physics describes time in ways that challenge our deepest intuitions. We'll explore how relativity dissolves the idea of a universal present, and eventually, we'll arrive at a place where time itself begins to blur, becoming something that may emerge from deeper structures, or perhaps something that was never quite what we thought it was. But for now, it's enough to simply notice the feeling, the quiet, familiar sense that time is always moving, even if we don't fully understand what that movement is. And perhaps, as you rest there, listening, letting your thoughts drift, you might begin to wonder, is time really passing, or is something else gently changing beneath it? If you sit quietly for a moment and listen closely, you might begin to notice something subtle, not just the passing of seconds, but the way those seconds feel. There is the steady rhythm of time as measured by a clock, calm, consistent, almost indifferent. And then there is the time you experience, shaped by emotion, attention, and memory, stretching and folding in ways the clock never reflects. It's almost as if there are two different kinds of time unfolding at once, one that belongs to the universe and one that belongs to you. Physicists and philosophers have long noticed this difference. Some have given it a simple name, a way to separate the two without confusion. They speak of physical time and what is sometimes called manifest time. Physical time is the time that lives inside the laws of physics. It is the kind of time that clocks measure. It ticks forward in equal steps, one moment to the next, without speeding up, without slowing down. It is the same time that allows satellites to orbit the Earth, that guides the motion of planets, and that keeps the delicate timing of systems like global navigation working with quiet precision. It does not care whether you're bored or excited or deeply lost in thought. It simply continues. Manifest time, on the other hand, is the time you live inside. It is shaped by how your mind processes the world. It depends on what you notice, what you remember, and what you anticipate. It stretches when you're waiting, compresses when you're engaged, and sometimes seems to disappear entirely when you are fully absorbed in a moment. You might think of it as a kind of inner landscape, where time is not measured in seconds but in experiences, and the difference between these two kinds of time can be surprisingly profound. Imagine again that quiet waiting room. There is nothing to do, nothing to hold your attention. Your mind begins to wander, searching for something to grasp. And in that absence of stimulation, each moment becomes more noticeable. The silence seems louder, the stillness feels heavier, time feels slow. Now imagine a different scene. You're walking through a busy street at night. Lights flicker gently in the distance. Conversations blend together into a soft hum. Your attention moves from one detail to another, a passing face, a familiar sound, a sudden thought. And before you realize it, time has passed. Not because the clock has changed, but because your mind was full. So perhaps the feeling of time is not about time itself, but about how much of the world you are taking in, moment by moment. There is an interesting idea that helps explain this. Some researchers suggest that the sense of duration, the feeling that something lasted a long or short time, may be connected to how many distinct memories are formed during that period. When more experiences are recorded, time feels longer in retrospect. When fewer experiences are stored, time feels compressed. This may be why childhood feels expansive. Nearly everything is new. Each day brings unfamiliar sights, sounds, and ideas. The brain is actively building its understanding of the world, laying down rich layers of memory. But as life becomes more familiar, as routines settle in, fewer new patterns are formed. Days begin to resemble one another, and when you look back, those days seem to blend together, becoming smaller somehow in memory. So in a quiet way, time may not only be something you experience in the present, it may also be something you reconstruct from the past. And yet, even knowing this, there remains a deeper question. If physical time is steady and unchanging, and manifest time is flexible and subjective, which one is real? It might seem natural to assume that physical time is the true version, and that our experience is simply an imperfect reflection of it. But things are not quite so simple, because when physicists describe the universe, they do not describe time as something that flows, they describe it as something that labels. In many of the equations used to describe motion and change, time appears as a kind of coordinate, similar to how we might describe position in space. If you imagine marking a point along a path, you might say, "This happened here, at this location." In a similar way, physics might say, "This happened at this moment." But the moment itself is not moving. It is simply a value, a marker, a way of organizing events, rather than something pushing them forward. To picture this more gently, you might imagine a long line of pages in a book. Each page represents a different moment. On each page, the universe is arranged in a slightly different way. Objects have moved, positions have shifted, patterns have changed, but the pages themselves are not flowing. They simply exist, and what we experience as the passage of time might be something like moving our awareness from one page to the next, or perhaps something even more subtle. Perhaps the pages are all there at once, and it is our mind that stitches them together, giving the illusion of movement. This idea can feel a little abstract at first, but it begins to make more sense when we notice how dependent our experience of time is on change. When nothing changes, when there is no movement, no sound, no new input, time becomes difficult to perceive. It can feel almost as if it has slowed to a near standstill, but introduce change, a shifting light, a moving object, a new thought, and suddenly time becomes visible again. It begins to flow. So perhaps what we are really sensing is not time itself, but change. Time in this view is not a river carrying events forward. It is more like a quiet backdrop against which change becomes meaningful. And our experience of time is the way our minds interpret that change, weaving it into a continuous story. This raises a gentle but powerful possibility. What if time is not something we move through, but something that emerges from the way we experience the world, a kind of structure built from memory, perception, and the unfolding of events, a soft framework rather than a force? As we continue, we'll begin to step outside of this personal inner experience and look at how the universe itself treats time, because when we do, we find something unexpected. Not only does time behave differently than we imagined, but even the idea of a shared present, a single now that everyone agrees on, begins to quietly disappear. There is a quiet assumption we carry with us, almost without noticing, that there is a moment called now, a sharp dividing line, separating the past from the future, a single point in time where everything exists just for an instant before slipping away. It feels precise, immediate, certain, and yet, when we begin to look a little closer, that certainty starts to soften, because the now you experience is not as simple as it seems. Imagine hearing a single musical note, just one. If it appeared and vanished instantly, with no connection to what came before or after, it would feel incomplete, almost meaningless, just a brief flicker of sound. But music is not made of isolated notes. It is made of sequences, patterns, a gentle unfolding of tones that overlap, blend, and echo into one another. When you listen to a melody, you're not only hearing the note that is playing right now, you're also holding on to the notes that came just before, while, at the same time, anticipating what might come next. In a very real sense, your experience of the present moment already contains the past, and leans into the future. It is not a point. It is a small window, a span, a kind of living interval, and this is not just a poetic idea. It reflects something very real about how your brain processes time. When an event happens in the world, light must travel to your eyes. That signal must then be converted into electrical activity, passed through layers of processing, and finally brought into awareness. This process takes time, not a long time, but enough. A fraction of a second, perhaps a third of a second, passes between the moment something happens and the moment you become aware of it, which means, quite gently, you're always experiencing the world slightly after it has already occurred. The now you feel is already in the past, and yet you don't notice this delay. Your experience feels immediate, continuous, seamless. That's because your brain does something remarkable. It gathers information from just a little bit of the past, blends it together, and presents it to you as a single, unified moment, a smooth surface stretched over a small stretch of time. This is what we might call a thick present. Not a razor-thin instant, but a softly extended duration. A moment with depth, and within that depth, something else is happening. Your mind is not only holding on to recent information, it is also quietly predicting what might come next. If you're listening to a familiar melody, you may find yourself anticipating the next note before it arrives. If someone is speaking, you may sense where their sentence is going before they finish it. In this way, your present moment is shaped not only by memory yours but by expectation. It is a blend of what has just happened and what is about to happen. And this blending creates the feeling of flow, not because time itself is moving, but because your mind is continuously updating a story a story that stretches slightly backward and slightly forward, forming a continuous thread. So when you feel that time is passing, that moments are flowing one into another, you may actually be feeling the way your brain stitches together experience, not the movement of time itself, but the movement of awareness across change. This idea becomes even more intriguing when we consider how fragile this sense of now can be. In certain situations, the continuity of time can break. Moments can feel disconnected, stretched, compressed, or even fragmented. Think of a moment of sudden surprise, when time seems to slow down, or a moment of deep focus, when hours seem to vanish, without notice. In both cases, the clock continues steadily, but your experience of the present changes dramatically, which suggests something important. The now you live in is not fixed. It is constructed, and like all constructions, it depends on the materials used to build it. Memory, attention, expectation, sensory input, all working together, quietly, continuously, to create the illusion of a seamless present. And perhaps most striking of all, there's no clear boundary where this present begins or ends. Try to locate it. Where does now start? Is it the instant you hear a sound, or the moment you become aware of hearing it, or the brief span during which the sound lingers in your mind? And when does it end? The moment the sound fades, or when your attention shifts elsewhere? The more you look for the edges of the present, the more they seem to dissolve. It is like trying to hold on to a shadow, always there but never fixed. This has led some thinkers to suggest something quite radical, that the present moment as a sharply defined slice of time may not exist at all. Instead, what we call now may be a useful illusion, a way for the mind to organize experience, to create continuity, to make sense of change. And if that is the case, then the familiar picture of time as a flowing river carrying us from past to future begins to feel less certain, because a river has a clear direction, a clear movement. But if the present itself is not a precise point, if it is instead a soft extended window, then perhaps the flow we perceive is not something happening in time, but something happening in us, a gentle unfolding of perception, moment by moment, shaped by the way our minds gather and interpret information. And this brings us to a quiet turning point, because so far we have been looking inward, exploring how time feels, how it is constructed, how it appears from within our own experience. But what happens when we step outside of that experience? When we look at time not as something we feel, but as something the universe describes? Does the universe itself contain a now? Does it recognize a present moment, or does it tell a very different story? One in which the idea of a shared present quietly disappears? As we begin to explore that question, we will find that the deeper we go, the less familiar time becomes. As your thoughts settle, and the idea of a thick present begins to gently take shape, we can begin to turn outward, away from how time feels and toward how time is described, because there is a quiet but important difference between experiencing something and explaining it. When physicists try to understand the universe, they do not begin with feelings, they begin with patterns, with relationships, with careful descriptions of how things change, and in those descriptions, time appears in a surprisingly simple way, not as a river, not as a force, not as something that flows, but as a kind of label, a coordinate, a way of keeping track of when something happens, rather than something that makes it happen. This might sound subtle at first, but it carries a profound implication. To see why, imagine something very familiar, a film. When you watch a movie, you experience motion. Characters move, scenes unfold, events flow naturally from one moment to the next. It feels continuous, alive. But if you pause the film and look closely, you will find that it is made of still frames. Each frame is a complete picture. Nothing inside it is moving. The sense of motion arises only when those frames are shown in sequence, one after another, at just the right pace. Now, in physics, something similar happens. When we describe how a system changes, we often describe its state at one moment, and then at another. We might say, very gently, this is how the system looks at one moment, and this is how it looks a little later. And the difference between those two descriptions tells us how things have changed, but the moment itself is simply a value, a point along a scale, a number we assign to organize events. It does not move. It does not push anything forward. It simply sits there, marking where we are in the description. In many equations of physics, time is represented in this quiet, almost humble way. It is treated much like a position in space. Just as you might describe where something is located, you also describe when it is happening. But there is no built-in sense that time is flowing from one value to the next. Instead, we can examine the system at one moment, then at another, or even imagine looking at it in reverse, tracing it backward. The laws themselves do not prefer one direction over the other, they simply describe relationships. This can feel a little surprising, because in everyday life, we are so used to thinking of time as something active, something that carries us forward, moment by moment. But in physics, that sense of movement is not part of the fundamental description. To make this idea a bit more tangible, imagine a long road stretching out into the distance. Along that road, there are markers. Each marker represents a different moment. You can stand at one marker or move to another, but the markers themselves are fixed. They do not move toward you or away from you. They simply exist. And if you were to describe your journey along that road, you might say, I was at this marker and now I am at that one. But the movement is not in the markers, it is in your path. In physics, time often plays a role very similar to those markers. It provides a structure, a way to arrange events, but it does not itself flow. This becomes even clearer when we consider that many physical laws work just as well. Whether we describe events moving forward or backward, imagine watching a glass fall from a table and shatter on the floor. If you record that event and play it backward, you would see fragments of glass rising up, assembling themselves, and returning neatly to the table. It would look unusual, but the basic physical interactions, forces, motions, could still be described by the same underlying rules. This symmetry suggests something quite intriguing. At a fundamental level, the universe does not seem to distinguish between past and future in the way we do. The equations themselves are neutral. They allow both directions, and yet, our experience is not neutral at all. We remember the past, but not the future. We see things break, but not unbreak. We feel ourselves moving forward, never backward. So there is a quiet tension here. On one side, the universe, as described by physics, appears calm, symmetrical, and indifferent to direction. On the other, our experience of time is rich, directional, and deeply tied to memory and change, and at the center of this tension sits a simple but profound idea. That time, in its most basic form, may not be a flowing entity at all. It may be something more like a coordinate system, a framework, a way of organizing events without imposing a direction. This idea can feel almost counterintuitive, because it challenges one of our most basic intuitions, that time is something that moves. But perhaps that intuition comes not from the structure of the universe, but from the structure of our experience, from the way our minds process change, build memories, and anticipate what comes next. As we continue, we will begin to explore how this simple, coordinate-like view of time was challenged and transformed by one of the most important ideas in modern physics. Because while early physics treated time as universal and steady, a deeper understanding revealed something far more surprising, that time does not pass at the same rate for everyone, that it can stretch and slow depending on motion and gravity, and that the idea of a single, shared timeline may be nothing more than a comforting illusion. If you follow this idea gently, that time in physics is more like a quiet coordinate than a flowing river, then you might expect something comforting, that even if time does not flow, at least it is the same for everyone, a universal rhythm, a shared ticking, echoing evenly across the entire universe. For a long time, this is exactly how people understood it. Isaac Newton imagined time as something absolute, a kind of invisible cosmic clock, ticking steadily in the background, completely independent of everything else. No matter where you were, no matter how fast you moved, no matter what you were doing, time in this view remained the same. A second here was the same as a second anywhere. It was a simple idea, elegant, reassuring, and it matched our everyday experience. But then, something unexpected happened. At the beginning of the 20th century, a quiet revolution began to unfold, and at the heart of it was a single, deeply puzzling observation. Light always moves at the same speed, no matter who measures it, no matter how fast they are moving. Imagine this for a moment. You are standing still, and you shine a beam of light forward. Now imagine someone else, moving very quickly in the same direction as that beam. Common sense would suggest that they would see the light moving more slowly relative to them, because they are already moving forward. But this is not what happens. They still measure the light moving at exactly the same speed, always, without exception. This simple fact forces something extraordinary. If two observers, moving differently, both measure light to behave in exactly the same way, then something else must be changing. And what changes is time, along with space. Einstein realized that to preserve the constancy of the speed of light, the universe must allow time itself to stretch and compress, not as an illusion, not as a trick of perception, but as a real, physical effect. To begin to picture this, imagine a very simple clock, not made of gears or hands, but of light, a beam of light bouncing between two mirrors, moving up and down. Each bounce marks a tick. Now imagine that this clock is at rest. The light travels straight up and straight down, tick, 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 in a steady rhythm. But now imagine that the clock begins to move sideways. As it moves, the light inside it no longer travels straight up and down. Instead, it traces a diagonal path, like a gentle zigzag. Because while it is moving up and down, the whole clock is also moving sideways, so the light has to travel a longer path between each tick, and yet, the speed of light remains the same. So if the distance becomes longer, and the speed does not change, then the time between ticks must increase. The clock runs more slowly, and this is not just something that happens to the clock, it happens to everything inside that moving system. All processes, all motions, all internal changes slow down together. From the outside, everything appears to unfold in slow motion. This is what we call time dilation, but we don't need to use that term. We can simply say, time stretches when things move very fast. And here is where it becomes even more subtle. Because motion is always relative. From the perspective of someone inside the moving system, it is the outside world that appears to be moving. So from their point of view, it is your time that runs more slowly. Both perspectives are valid. There is no single absolute frame that defines what is truly at rest. Time becomes personal, local, dependent on the path you take through the universe. And this is not just a thought experiment. It is something that has been measured, carefully, repeatedly, with remarkable precision. Particles created high in the atmosphere, travelling at speeds close to that of light, live longer than they otherwise would, not because their internal structure has changed, but because, from our perspective, their time is passing more slowly. And even in everyday technology, this effect must be taken into account. Satellites orbiting the Earth, carrying precise clocks, experience time differently than clocks on the ground, partly because they are moving, and partly because they are farther from the pull of gravity. Their time runs at a slightly different rate, and unless we correct for this difference, systems that rely on precise timing, like navigation signals guiding your phone, would quickly drift out of alignment. So this is not abstract. It is woven into the way the world works, quietly, invisibly, but undeniably real. And with this realization, something important begins to dissolve. The idea of a universal time, a shared now that everyone agrees on. Because if time can stretch, if it can slow, if it depends on motion and position, then two observers, moving differently, will not agree on how much time has passed, or even on what events are happening at the same moment. What feels like now to one observer may not be now for another, and this leads us gently toward a deeper question. If time is not absolute, if it is not shared, if it is not the same everywhere, then what becomes of the present? Is there a single moment unfolding across the universe? Or is the idea of a universal present something we have quietly assumed without ever truly examining it? As we continue, we will begin to see that even this familiar idea, the simple notion of now, begins to blur and soften until it becomes something far less definite than we ever imagined. There's a gentle shift that happens once you begin to accept the time is not the same everywhere, that it can stretch and slow depending on motion. At first it feels surprising, but then something even quieter and perhaps even more beautiful and begins to emerge. Because motion is not the only thing that changes time. Gravity does too, and not in a metaphorical sense, not as a poetic idea, but as something real, measurable, and quietly present in the world around you. To begin to feel this, imagine standing at the base of a mountain. The ground beneath your feet feels steady, solid, familiar. Now imagine climbing, slowly, upward, step by step. The air grows thinner, the horizon widens, the world stretches out beneath you. But something else has changed, though you cannot feel it directly. Time is moving slightly faster at the top of the mountain than it is at the bottom. Not enough for you to notice, not enough to change your day, but enough to be measured, enough to be real. This idea comes from a deeper understanding of gravity. In everyday life, yes, we often think of gravity as a force, something that pulls objects downward toward the earth. But in a more complete picture, gravity is not just a force, it is a shape, a gentle curvature in the fabric of space and time itself. Mass bends this fabric, the earth, the sun, even your own body. creates a tiny distortion in the structure of the universe around it. And when something moves within that curved structure, it follows the shape that has been created. Now, here is where time quietly enters the picture. When space is curved, time is affected as well. Near a massive object, where the curvature is stronger, time moves more slowly. Farther away, where the curvature is gentler, time moves more quickly. You might picture it, not as a force pushing on time, but as a change in the rhythm of reality itself, a slowing and a quickening, depending on where you are. To make this a little more tangible, imagine two identical clocks. One remains on the ground, close to the Earth's surface. The other is lifted high above, perhaps carried by a satellite orbiting quietly in space. Both clocks are precise, both tick with perfect regularity, and yet they do not agree. The clock farther from Earth, where gravity is weaker, ticks just a little faster, while the one closer to Earth, deeper in the gravitational field, ticks a little slower. It is a tiny difference, but over time, it adds up. And just like the effects of motion, this difference must be accounted for in the systems we rely on. When signals are sent from satellites down to your phone, helping it determine your position, those signals depend on extremely precise timing. If we ignored the fact that time runs differently in orbit, the calculations would drift, and your location would slowly become inaccurate, so we quietly correct for it. We adjust the clocks, not because they are broken, but because time itself is behaving differently. And this leads us toward a deeper realization. Time is not something that flows uniformly through the universe. It is something that depends on your path, on your motion, on your position within the gravitational landscape. In a very real sense, each of us carries our own time, our own rhythm, shaped by the journey we take through space and gravity. And this idea can be extended further. If you were to travel near something extremely massive, like a black hole, the effect would become dramatic. Time near such an object would slow down significantly compared to regions far away. Moments could stretch, processes could unfold more slowly, from the perspective of a distant observer. But from within that region, everything would feel normal. Your heartbeat would remain steady. Your thoughts would flow as usual, because your experience is always tied to your own local time, and this is perhaps one of the most gentle, and yet profound, shifts in perspective that modern physics offers. There is no single clock ticking for the entire universe, no universal rhythm shared by all observers. Instead, there are many clocks, many timelines, each one valid, each one real, each one shaped by motion and gravity. And once this becomes clear, something else begins to fade. The idea that there is a single, shared moment happening everywhere at once. Because if time itself is not synchronized, if it stretches and compresses depending on where you are, then how could there be a single now that applies to everyone? What you consider to be the present may not align with someone else's present if they are moving differently or standing in a different gravitational field. Their now may include events that you would place in the future, or exclude events that you believe have already happened. And this is not because either of you is mistaken, it is because the universe does not provide a universal present. It provides only local perspectives, local experiences, local slices of time. So the question begins to shift. Instead of asking, "What time is it?" we might ask, "For whom?" And in doing so, we begin to loosen our grip on one of the most familiar ideas we have ever known, that there is a single, shared present moment, unfolding everywhere, all at once. Because as we move forward, we will see that this idea, this simple, comforting notion of now may be one of the first things we must gently let go of. There is a quiet idea we carry with us, almost without question, that somewhere, across the vastness of the universe, there exists a single moment, a shared present, a universal now. It feels natural. You might imagine that right now, as you're listening, there is a single slice of time stretching outward in all directions, that everything happening across the stars, across distant galaxies, is unfolding together in the same instant. But as we've begun to see, time does not behave so simply. It bends, it stretches, it depends on motion and gravity and perspective. And when we follow these ideas just a little further, something surprising begins to emerge. The universe does not offer a universal present at all. To begin to feel this, imagine a simple scene. You're standing on an open field beneath a quiet sky. Far in the distance, two flashes of light appear, one to your left and one to your right. They reach your eyes at exactly the same moment. So naturally, you conclude that they happened at the same time, simultaneously. Now imagine someone else. They are moving past you, very quickly, gliding across the field in a smooth, steady motion. They also see the two flashes, but because they are moving, their experience is slightly different. From their perspective, one flash reaches them before the other, and when they carefully analyze what they see, they come to a different conclusion. For them, the two events did not happen at the same time. One occurred first, the other came later. So now we have something quite remarkable. Two observers, both careful, both correct, and yet they disagree about what happened first. This is not a mistake. It is not an illusion. It is a natural consequence of how space and time are structured. What one observer calls now, another may divide into before and after. And this difference is not something that can be resolved by checking more carefully. There is no deeper, hidden clock that both observers can appeal to, no universal reference that settles the matter once and for all, because such a clock does not exist. The ordering of events depends on the observer, on their motion, on their path through the universe. This idea is known as the relativity of simultaneity. But we don't need to use that phrase. We can simply say, there is no absolute agreement on what happens at the same time. And once you accept this, something profound begins to shift. Because if there is no universal agreement on simultaneity, then there can be no universal present, no single moment shared by all observers across all of space. Instead, each observer carries their own version of now, a local slice of time shaped by their motion and position, and these slices do not always line up. To make this even more vivid, imagine extending this idea across vast distances, across light years, across galaxies. Events that appear simultaneous to you may be ordered differently by someone far away, moving in a different way. What you consider part of your present might, from another perspective, belong to their past or their future. It's not that one of you is wrong, it's that the universe doesn't privilege any single viewpoint. There is no master timeline ticking in the background, defining a global now. There are only many perspectives, each internally consistent, each equally valid, and yet, despite all of this, you still feel a present moment, a clear, immediate now, a sense that everything is happening together, right here. This feeling is not an error. It is a feature of how your mind organizes experience. It gathers information from your surroundings, aligns it within your own frame of reference, and presents it as a coherent present. A personal now, but that now doesn't extend across the universe. It is local, intimate, tied to your position, your motion, your path. And this leads to a gentle but unsettling realization: the present moment, as something universal, does not exist. There is no single, shared slice of time cutting across the universe, separating past from future. Instead, there is a vast tapestry of events woven together in a structure where before and after can depend on how you move through it. This may feel strange at first, even a little disorienting, because it challenges one of the most basic ways we understand the world, but it also opens the door to a new way of seeing time, not as a flowing river with a single current, but as something more like a landscape, a structure, where different paths reveal different orderings, different relationships, different perspectives, and within that landscape, your experience of now is just one path among many, valid, real, but not universal. As this idea settles, something else begins to come into view. If there is no universal present, if past and future can blur depending on perspective, if time does not flow in a single, shared direction, then perhaps time is not something that unfolds, step by step, but something that already exists, all at once, a complete structure where every moment has its place, and what we experience as movement, as change, as the passage from one moment to the next, may be something deeper, something tied not to time itself, but to how we move through it. There is a quiet shift that happens when we begin to let go of the idea of a universal now. At first, it feels like something is missing, a sense of grounding, a shared moment, a single thread connecting everything together. But as that thread softens, something else begins to appear in its place, a different way of seeing time, not as something that flows, but as something that simply exists. To begin to feel this, imagine a book, not a story you're reading line by line, but the entire book, all at once. Every page is already there, the beginning, the middle, the ending, all resting quietly together. Now imagine that each page represents the entire universe. At one moment, on one page, stars are forming. On another, planets drift through space. On another, you're sitting here, listening. Each page is complete. Nothing is moving within it. It simply captures a particular arrangement of everything, frozen in place. And when we place all of these pages together, stacked gently one after another, we begin to form something like a structure, a whole, not a sequence that unfolds, but a collection that already exists. This is one way to begin to picture what physicists mean when they say that time may be another dimension. Just as space has dimensions, directions you can move in, time can be thought of as an additional direction, one that organizes events into a larger structure. We cannot move freely in this direction the way we move through space, but that does not mean it is not there. It may simply be a different kind of direction. To make this a little more tangible, imagine a simple three-dimensional world. You can move left and right, forward and backward, up and down. Now imagine adding one more dimension, not one you can easily see, but one that allows you to locate events, not just by where they happen, but when they happen. Together, space and time form a single structure, not separate, but unified. Every event, every moment, every configuration of the universe exists somewhere within this larger structure. And once we begin to see time this way, something subtle changes. Instead of thinking of the universe as something that is constantly becoming, we begin to think of it as something that already is, a complete tapestry, woven together from all moments, rather than a story being written in real time. This idea is often described as a kind of block universe. Not a block in the sense of something rigid or lifeless, but a structure where all events are laid out across both space and time, past, present, and future, not as separate realms, but as different regions within the same whole. To return to the book analogy, it is not that the story is being written as you read it. It is that the entire story already exists, every chapter, every page, and what you experience as reading is simply moving through that structure, one page at a time. But even this idea needs to be handled gently, because it can easily feel too abstract, too distant. So instead, let's bring it closer. Imagine taking a single photograph. In that image, everything is fixed, a moment captured, held still. Now imagine taking another photograph, just a little later, and another, each one slightly different, reflecting the small changes that occur over time. Now imagine stacking all of these images together, not in motion, not playing like a film, but resting, one on top of another, forming a layered structure. Each layer represents the universe at a different moment, and together they form something larger. Not a sequence that is unfolding, but a collection that already exists. If you are somehow able to step outside this structure and see it all at once, you would not see time flowing. You would see all moments equally present, equally real. And this is where the idea becomes both beautiful and a little unsettling, because if all moments exist, then the distinction between past, present, and future begins to blur. The past is not gone. The future is not yet to be. They are simply located in different regions of this larger structure. The present, the now you experience, is not a universal slice cutting across everything, but a particular position along your path, a place within the structure where your awareness happens to be. And this leads to a quiet question. If all moments exist, then what does it mean to say that time is passing? What is it that is moving? Is it time itself? Or is it something else? Something more subtle that gives rise to the feeling of movement? As we continue, we will begin to explore this idea more deeply. We will follow the path of a single life as it stretches across this structure, forming something known as a world line. And in doing so, we may begin to see that what we think of as moving through time might actually be something quite different. As the image of a block universe begins to settle, with its quiet layers of moments resting together, we can gently bring the idea a little closer to something more personal, because within that vast structure, filled with stars, galaxies, and unfolding events, there is also you, your life, your experiences, and your memories, all woven into that same fabric. And to understand how that works, physicists often use a very simple idea. They imagine your life, not as something moving through time, but as something that is already laid out. Cross it. They call this path a world line, but we don't need to hold on to the word itself. We can simply imagine it. Picture a long thread stretching through the structure we just explored. At one end, the beginning of your life, at the other, its far horizon, wherever that may be. And between those points, every moment you have lived and will live is gently arranged along that thread, not in motion, not unfolding, but existing as part of a continuous path. Now, to make this feel a little more tangible, imagine again that stack of images. Each image represents the entire universe at one moment. If we were to look only at you, within each of those images, we would see something subtle. In one image, you are here. In the next, you have shifted slightly. In another, you've taken a step, or turned your head, or changed your expression. Each version of you, slightly different, but connected. And if we were to trace those versions from one image to the next, we would begin to see a path, a line, weaving gently through the layers. That line is your life. Not something moving, but something extended, something that has shape, something that occupies not just space, but time as well. And this idea invites a quiet shift in perspective, because we're used to thinking of ourselves as existing only in the present moment, as if we are a single point, moving forward through time, leaving the past behind and approaching the future. But in this picture, you're not just a point, you are a path, a continuous presence, stretching across many moments, each one connected to the next. Your childhood, your present, your future are not separate things that appear and disappear. They're all part of the same structure, different regions along the same thread. And just as a road can curve and bend through a landscape, your path through the universe is shaped by how you move and where you are. If you were to remain completely still, not moving through space at all, your path would be simple, almost straight, extending gently along the direction of time. But of course, we are never truly still. Even now, Gyanan, as you sit or lie quietly, you are moving. The earth beneath you rotates. It travels around the sun. The sun itself moves through the galaxy. And so your path is not a straight line. It is a soft curve, winding through space and time together. This is why physicists think of space and time not as separate, but as deeply intertwined, because your motion through space affects your journey through time, and your position in time cannot be separated from where you are. So instead of imagining yourself moving through time like a traveller on a river, you might imagine yourself as something more like a shape, a presence extended across many moments, a quiet curve drawn into the structure of the universe. And this brings us back to a question that may feel both simple and surprisingly difficult. If your life is already laid out in this way, if every moment exists as part of a continuous path, then what does it mean to say that you are moving? What is it that is changing? Because from within this picture, nothing is actually travelling along the path. The path itself simply is, all its points, all its moments, equally present within the larger structure. And yet, you still feel something very different. You feel yourself here, in this moment, not in your past, not in your future, just here, aware, present. So perhaps what is moving is not your existence, but your awareness, your experience, moving along that path, moment by moment, giving the impression of passage, like a light, tracing along a line, illuminating one point at a time, or like reading the pages of a book, one after another, even though the entire story already exists. This idea can feel both calming and a little strange, because it suggests that your future, in some sense, is already part of the structure, not something waiting to be created, but something already present, just not yet experienced. And your past is not gone. It is simply a region you're no longer focused on, all of it held together within the same quiet framework. But before this idea settles too deeply, there is an important question waiting just beneath the surface. If all moments exist, if your life is already laid out across time, then what about choice? What about possibility? What about the sense that the future is open and not yet determined. Does this picture leave room for that? Or does it suggest something more fixed, more unchanging than we might be comfortable with? As we continue, we will gently explore these possibilities, because there are different ways of thinking about time, different interpretations, each offering a slightly different answer to what is real and what is simply experienced. As the idea of your life as a continuous path begins to settle, a quiet question starts to rise. If every moment of your life is already part of a larger structure, if your past, your present, and your future all exist along that path, then what exactly is real? Is only this moment real, the one you're experiencing right now, or are all moments equally real, whether you're aware of them or not? This question has been explored for centuries, not only by physicists, but by philosophers, each offering a different way of understanding time. And at the heart of this exploration are a few simple but powerful perspectives. The first is perhaps the most intuitive. It is the idea that only the present moment exists, that the past is gone, no longer real, and the future has not yet happened, and therefore does not exist either. All that remains is now. This view is often called presentism, but we don't need to hold on to the name. We can simply feel what it suggests. That reality is like a spotlight, illuminating a single moment, while everything else fades into non-existence. It aligns closely with how we experience the world. We remember the past, we cannot return to it. We anticipate the future, but we cannot touch it. We exist, only here, only now. And yet, when we place this idea alongside what we have seen in physics, something begins to feel uncertain. Because in the structure of space-time, there is no special slice labelled now. There is no universal present, shared across all observers. Different perspectives lead to different orderings of events. So which moment would we choose as the one that truly exists, whose now would define reality? This leads us gently toward another view, one that may feel less intuitive, but more consistent with the structure we have explored. It is the idea that all moments exist, not just the present, but the past and the future as well. Each moment as real as any other, not appearing, not disappearing, but simply existing within the larger structure of space-time. This view is often called eternalism, but, again, the name matters less than the feeling. Imagine once more that book, resting quietly with all its pages intact, the beginning of the story still there, the ending already written, every chapter equally present within the whole. When you read the book, you move from one page to the next, but the pages themselves do not come into existence as you read them. They're already there. In this way, your experience of moving through time may be similar, a journey of awareness across a structure that is already complete. This idea can feel a little unsettling at first, because it seems to suggest that the future is not open, that it is already there, waiting, fixed within the structure. And this brings us to a deeper concern. What about choice? What about the feeling that your decisions matter, that the future is shaped by what you do? If everything already exists, then what becomes of that freedom? There are many ways to respond to this question. One gentle way is to recognize that even if the future is part of the structure, you do not have access to it. You cannot see it. You cannot step outside your path and look ahead. From within your experience, the future remains unknown. And because it is unknown, your choices still feel real. They still carry meaning. They still shape the way your path unfolds. from your perspective. Another way to think about this is to imagine walking through a landscape. The path ahead may already exist, but as you walk, you do not see the entire path at once. You make decisions, turn left or right, explore different directions. Even if the landscape is fixed, your experience of moving through it remains dynamic, alive, and meaningful. There are also other ways of understanding time that sit somewhere between these two views. Some suggest that the past and present exist, but the future is still being formed, like a growing structure, extending forward, moment by moment. Others imagine a kind of moving spotlight, where all moments exist, but only one is illuminated at a time, creating the experience of a flowing present. Each of these ideas attempts to reconcile two things: the structure suggested by physics and the experience we carry within us. But what is perhaps most striking is that many modern theories in physics, especially those that try to unify our understanding of the very small and the very large, tend to align more naturally with the idea that all moments exist. That time is not something that comes into being, moment by moment, but something that is already part of the structure of reality. And yet, even here, there is room for wonder. Because knowing that all moments may exist does not diminish the experience of living them. You still feel joy, you still feel curiosity, you still move through your own awareness from one moment to the next. And that movement, that unfolding of experience, remains as real and as meaningful as ever. So perhaps, instead of asking whether time is real, we might ask a softer question. What kind of reality does time have? Is it something fundamental, woven into the fabric of the universe, or is it something that emerges from deeper patterns, from relationships, from the way things are connected? As we continue, we will begin to explore this possibility. That time itself may not be a basic ingredient of the universe, but something that arises from something even deeper, a structure beneath the surface, where time, as we know it, has yet to fully take shape. As the idea of a complete structure, a universe where all moments quietly coexist, begins to settle in your mind, there is a gentle step we can take, a little further still. Because even this picture, the one where time exists as a dimension, may not be the deepest layer of reality. There is a possibility, soft but profound, that time itself may not exist at all at the most fundamental level. This idea does not come from imagination alone. It arises from an attempt to answer one of the most difficult questions in modern physics. How do we describe the universe when we bring together the very large and the very small? On one side, we have our understanding of gravity, which describes how planets move, how stars form, how space and time curve around massive objects. On the other side, we have quantum theory, which describes the delicate behavior of particles, the tiny building blocks of reality. Both are remarkably successful in their own domains, but when we try to combine them to describe the entire universe at once, something unexpected happens. Time begins to fade. In one of the approaches physicists use to explore this, they arrive at a description of the universe that does not include time as a fundamental ingredient, not as a flowing river, not even as a dimension, simply not there. This idea is often associated with a particular equation, one that attempts to describe the entire universe in a single, unified way. But rather than focusing on the equation itself, we can gently focus on what it suggests. Imagine trying to describe the universe, not as something evolving, but as something complete, a whole. Instead of asking, how does the universe change from one moment to the next? We ask, what is the full structure of the universe? All at once. In that kind of description, there is no need for time to move. There is no before and after. There is only the structure as a whole. To picture this, imagine a vast detailed painting. Every element is already there. Every colour, every shape, every texture exists simultaneously within the image. There is no unfolding, no sequence, no progression. And yet, the painting can still contain patterns, relationships, connections between different parts. Now imagine that this painting is not static in a simple sense, but rich with internal structure. Within it, there are regions that resemble what we would call earlier and later, not because time is flowing, but because of how those regions are arranged. From within the painting, if you could somehow experience it from the inside, you might perceive change, you might feel a sense of progression, of movement, of time passing, but from the outside, the painting simply is, complete, unchanging. And this is the quiet suggestion that emerges from some of our deepest attempts to understand the universe, that at the most fundamental level, there may be no ticking clock, no flowing time, only a structure containing all possible configurations, arranged in a way that gives rise to the appearance of change. This idea can feel almost paradoxical, because our entire experience is built around time. We remember, we anticipate, we feel ourselves moving from one moment to the next. So how could time not exist? One way to begin to reconcile this is to think about how other familiar concepts emerge. Take temperature, for example. When you touch something warm, you feel heat. It seems real, immediate, undeniable. But at a deeper level, temperature is not a fundamental ingredient of reality. It emerges from the motion of many tiny particles, from the way they move and interact. If you look closely enough, there is no single particle that has temperature. Temperature is a collective effect, a pattern that appears when many parts come together. In a similar way, it is possible that time, as we experience it, is not fundamental, but emergent. A result of deeper relationships within the structure of the universe. From within that structure, patterns of change appear, sequences emerge, and our minds, sensitive to these patterns, interpret them as the passage of time. But beneath that experience, there may be something more still, more quiet, a layer of reality where the familiar flow of time has not yet taken shape. And this leads to a gentle but important question. If time is not fundamental, if it arises from deeper structures, then what are those structures? What is it that gives rise to the patterns we interpret as time? As we continue, we will begin to explore one of the most intriguing possibilities, that the key may lie in the way different parts of the universe are connected, in the relationships between systems, in the subtle correlations that link one part of reality to another, and that from those connections, from those quiet patterns of relationship, time itself may begin to emerge. As the idea of a timeless universe gently settles, there is a natural question that begins to form. If time is not fundamental, if it's not built into the deepest layer of reality, then where does it come from? Because time, in all its familiar forms, still appears. Clocks tick, hearts beat, memories accumulate, the world changes, moment by moment. So time may not be fundamental, but it is certainly present, and this leads us toward a quieter, more subtle idea. That time may be something that emerges, not something that exists on its own, but something that arises when deeper elements of reality come together in a certain way. To begin to feel what this means, we can look at something very familiar: water. When you touch water, you experience wetness. It feels immediate, undeniable, almost like a basic property of the world. But if you look closely enough, at the level of individual molecules, there is no such thing as wetness. A single molecule of water is not wet. It is simply a small structure made of atoms, moving and interacting. Wetness appears only when many molecules come together, when they form patterns, when they flow, when they interact with surfaces and with each other. It is a collective effect, something that emerges from many simple parts. Temperature is similar. When you say something is warm or cold, you're describing a property that does not exist at the level of a single particle. Instead, it reflects the average motion of many particles. The faster they move, the warmer the system feels. But again, temperature is not fundamental. It is a description that emerges from deeper behavior. And this idea of emergence appears again and again throughout science. Simple rules, giving rise to complex patterns, local interactions, creating global structure. And so, it is natural to ask, could time be like this? Could it be something that appears when many parts of the universe interact in just the right way? A kind of large-scale pattern emerging from a deeper, more fundamental layer. There are different ways to think about this. Some forms of emergence are relatively straightforward. They arise directly from the underlying components and can, in principle, be traced back to them. Others are more subtle, more difficult to reduce, appearing almost as new kinds of phenomena with their own rules and behaviours. So the question becomes, what kind of emergence might time belong to? Is it something like temperature, a smooth, predictable result of many interactions? Or is it something deeper, more mysterious, closer to the way consciousness itself seems to arise, a phenomenon that is built from simpler parts, and yet not easily explained by them? At the moment, we do not have a complete answer, but we do have clues. One of the most important is this: time seems to be closely tied to change. Where there is change, there is a sense of time. Where there is no change, time becomes difficult to detect. If everything were completely still, if nothing moved, nothing shifted, nothing evolved, there would be no way to distinguish one moment from another. And in that sense, time would lose its meaning. So perhaps time is not something that exists independently, but something that arises from the relationships between different parts of the universe, from the way systems interact, influence one another, and evolve. Another clue comes from the way we measure time. We do not measure time directly. We measure processes, the swing of a pendulum, the vibration of atoms, the rotation of the earth. Each of these is a form of change, and we use these changes as a way of marking time. So in a quiet way, time is already defined through change, not as something separate, but as something inferred. And this leads to a gentle shift in perspective. Instead of thinking of time as a stage on which events occur, we might begin to think of it as something that arises from the events themselves, a kind of pattern woven from the relationships between states of the universe, not a background, but a consequence. And when we return to the idea of a timeless structure, this begins to make sense. If the universe at its deepest level is described all at once, without a flowing time, then the appearance of time must come from within that structure, from the way different parts relate to one another, from the patterns that allow us to say, this comes before that, or this leads to that. In other words, time may not be a fundamental ingredient, but a kind of language, a way of describing how the universe is organized. And yet, even as we begin to see time in this way, another question begins to take shape. If time emerges from relationships, then what kind of relationships are responsible? What is the underlying mechanism that gives rise to the patterns we interpret as time? As we continue, we will explore one of the most intriguing possibilities, that the key may lie in a deep and subtle connection, one that links different parts of the universe, even across distance, a connection that does not behave like anything we encounter in everyday life, a kind of quiet relationship, where the state of one system is tied to another in a way that cannot be fully separated. And from that relationship, from that hidden structure, time itself may begin to take form. As the idea of time as something that emerges begins to take shape, a deeper question gently follows. If time is not fundamental, if it arises from relationships, then what kind of relationships are powerful enough to give rise to something as rich as the experience of time? To begin to explore this, we can turn to one of the most intriguing features of the quantum world, a kind of connection that does not behave like anything we encounter in everyday life, a connection known as entanglement. But rather than focusing on the word itself, we can begin with the feeling of it. Imagine two systems, two simple objects, created together in a shared process. At the moment of their creation, they are linked, not by a visible thread, not by a signal travelling between them, but by a deeper relationship, a shared description. Now imagine separating them, moving them far apart, across a room, or even across vast distances. Despite that separation, the relationship remains. If you carefully examine one, you immediately gain information about the other, not because something is travelling between them, but because they were never fully independent to begin with. They are parts of a single unified description. This is not something we can easily visualize, and that is perfectly all right. It is enough to hold on to the idea that in the quantum world, separation is not always what it seems. Now, how could something like this be related to time? To explore that, let us return to the idea of a universe that does not contain time at its deepest level, a complete structure where everything exists at once. Within that structure, there are many parts, many systems, interacting, relating, forming patterns, and among those systems, some may act as references for others. Imagine one part of the universe behaving in a regular, predictable way, a kind of internal clock, not a clock in the traditional sense, but a system whose states change in a consistent pattern. Now imagine another part of the universe, whose behaviour is linked to that first system, not by direct interaction in time, but through a shared relationship, a correlation. As the first system takes on different configurations, the second system reflects corresponding changes. From within the structure, if you focus on the relationship between these two systems, it can begin to look as though one is evolving with respect to the other, as though time is passing. But in this picture, nothing is actually moving through time. There is only a pattern, a relationship between different parts of the whole. And that relationship gives rise to the appearance of change, the appearance of sequence, the appearance of time. To make this feel a little more intuitive, imagine two dancers. They are performing a carefully choreographed routine. If you watch one dancer in isolation, their movements may seem abstract. But when you watch both together, you begin to see a pattern, a coordinated unfolding. Each movement of one dancer corresponds to a movement of the other. And from that relationship, a sense of progression emerges. Not because time is driving the dance, but because the structure of the choreography creates a pattern that unfolds. In a similar way, some physicists have suggested that time may emerge from the relationships between systems, especially when those systems are deeply linked at the quantum level. One system provides a kind of reference, a sequence of states. Another system, when viewed relative to that reference, appears to change. And from that comparison, time appears. This idea can be difficult to grasp at first, because we are so used to thinking of time as something external, something that exists independently of the systems it describes. But here, time is not external. It is relational. It arises from the way systems are connected, from the way their states correspond to one another. And this leads to a quiet but powerful shift in perspective. Instead of asking, how does a system evolve in time? We might ask, how do different parts of the universe relate to one another? And from those relationships, time may emerge as a way of describing the pattern. Now, it is important to hold this idea gently. It is not a final answer. It is one of several ways physicists are exploring the nature of time at the deepest levels, but it offers something valuable, a way of understanding how time, which seems so fundamental, could arise from something more basic, from connections, from correlations, from the quiet structure of the universe itself. And this idea connects naturally to something we have already touched upon, the arrow of time, the sense that time moves in one direction, from past to future. If time emerges from relationships, then perhaps the direction of time also emerges from how those relationships develop, from how connections spread, from how systems become more intertwined, more correlated, more complex. As we continue, we will begin to explore this idea more fully. We will see how the simple notion of disorder, of things becoming more mixed, more spread out, may be connected to the direction we experience, and how the quiet growth of relationships across the universe may shape the way time seems to move, always forward, never back. As the idea of time emerging from relationships begins to settle, another question quietly rises to the surface. If time comes from patterns, from connections, from the way things relate, then why does it seem to move in only one direction? Why does everything appear to flow from past to future and never the other way around? Because in your experience, the direction feels undeniable. You remember yesterday, but not tomorrow. You watch a glass fall and shatter, but never see the pieces rise and reassemble. You feel yourself moving forward, step by step, never backward. It feels so natural, so deeply woven into reality, that it's easy to assume this direction is built into the universe itself. And yet, when physicists look closely at the fundamental laws that describe how things behave, they find something surprising. Those laws do not seem to prefer a direction at all. To begin to feel this, imagine recording a simple event. A glass sitting on a table, it tips, falls, and breaks into many pieces on the floor. Now imagine playing that recording backward. The scattered pieces slide, together thus forming the glass once more, which then rises gently back onto the table. At first, it feels strange, unnatural, but if you focus only on the motion itself, something subtle becomes clear. The movements still follow the same kinds of rules. Objects move smoothly, forces act continuously. There is nothing in the motion itself that clearly violates the basic laws of physics. The difference is not in the laws, it is in your expectation. You're used to seeing things break, not unbreak, but the underlying rules that govern motion often allow both directions. In many of the equations used in physics, if you describe a process moving forward and then reverse the direction, the equations still hold. They do not say, "This must happen forward in time." They simply describe relationships between positions, motions, and interactions. They are neutral. They do not distinguish between past and future. This idea is sometimes called time symmetry, but we can simply say, the deepest rules of physics do not seem to care which way time goes, and this creates a quiet puzzle. Because if the laws themselves are neutral, then where does the direction we experience come from? Why does the world feel so strongly oriented from past to future? To begin to explore this, let's return to something very simple. Imagine watching a ball roll across the floor. If you play that motion backward, it looks almost the same. The ball rolls smoothly in the opposite direction. Nothing feels especially strange. But now imagine something more complex, a drop of ink spreading through a glass of water. At first, the ink is concentrated in one place. Then it begins to spread, swirling gently, mixing with the water until it becomes evenly distributed. If you play that process backward, the ink gathers itself together, forming a tight, concentrated drop once again. This time, the reversal feels deeply unnatural, not because the basics, motions are impossible, but because the pattern of change feels wrong. We do not expect things to spontaneously become more ordered. We expect them to spread, to mix, to become less structured over time. And this expectation is not arbitrary. It reflects a deeper pattern in the universe, a tendency for things to move from more ordered states to more spread out, less ordered ones. This tendency gives rise to what we experience as the direction of time. But notice something important. The direction is not coming from the fundamental laws themselves. It is emerging from the behavior of large systems, from the way many small parts interact together at the level of individual interactions. The laws remain neutral, but when many interactions combine, patterns begin to form, patterns that favour one direction over the other, and from those patterns, the arrow of time appears. This idea becomes even clearer when we think about memory. You remember the past because information about it is stored in your brain, in the world around you, but the future has not yet left those traces. There are no memories of tomorrow, no records, no imprints, no stored information, so your experience naturally aligns with the direction in which information accumulates, from states that contain less information about what has happened to states that contain more, and this accumulation gives the feeling of moving forward. But again, this direction is not imposed by the fundamental laws. It arises from how systems behave when many parts interact and information spreads. So we arrive at a gentle but powerful realization. The direction of time is not something written into the deepest rules of the universe. It is something that emerges, a pattern formed from the collective behavior of many interacting systems, and your experience of that direction is tied to how your mind processes information, builds memories, and anticipates what comes next. Time feels like it flows forward, because everything around you and within you is organized in that direction. But beneath that experience, the underlying laws remain calm, symmetrical, indifferent to the arrow you perceive, and this brings us closer to understanding the nature of time itself, because if the direction of time is not fundamental, then perhaps it is something that can be explained, something that arises from deeper processes, from the way order changes, from the way information spreads, from the way systems become more intertwined over time. As we continue, we will begin to explore this idea more fully. We will look at how the simple tendency for things to spread out, to become more disordered, can give rise to the powerful sense that time moves forward, even in a universe where the deepest laws remain perfectly balanced and still. As the idea of time having no preferred direction at the deepest level begins to settle, there is a quiet tension that remains, because even if the laws themselves are neutral, your experience is not. You feel a direction. You see it everywhere, in the way things change, in the way moments unfold, in the way the world quietly drifts from what was into what will be. So where does that direction come from? To begin to understand this, we can look at something very simple. A cup of hot coffee, freshly poured. It steams gently, warmth rising into the air. If you leave it alone, something predictable happens. It cools. The heat spreads from the coffee into the surrounding air until both reach a similar temperature. You have seen this happen countless times, and yet you've never seen the reverse. You've never placed a cup of cold coffee on a table and watched it slowly grow warmer, drawing heat from the air around it until it becomes hot again. The difference between these two possibilities, forward and reverse, lies at the heart of what we call the arrow of time, and to understand that difference, physicists often use a concept known as entropy. But rather than focusing on the word itself, we can begin with the feeling of it. Imagine a neat, orderly room, books placed carefully on a shelf, clothes folded, everything arranged with intention. Now imagine that same room after days of use, without attention. Objects are scattered, clothes lie unfolded, books are out of place. The room has not been destroyed, but it has become more spread out, less ordered, less structured. This shift from order to disorder is a simple way to begin to feel what entropy describes. It is not about chaos in a dramatic sense. It is about how spread out, how dispersed, how many possible arrangements a system can have. A neat room can be arranged in only a few specific ways. A messy room can exist in many different configurations. So there are far more ways for the room to be messy than for it to be perfectly ordered. And because of that, systems naturally tend to move toward those more probable states, toward configurations that can exist in many different ways. And this is what we see in the cooling of coffee. At first, the heat is concentrated. Most of the energy is held within the liquid itself, but over time, that energy spreads. It disperses into the air, into the surroundings, becoming more evenly distributed. And there are many more ways for that energy to be spread out than for it to remain tightly concentrated. So the system naturally evolves in that direction, not because it is forced, but because it is overwhelmingly more likely. This is the quiet engine behind the arrow of time, the tendency for systems to move from less probable arrangements to more probable ones, from concentrated to dispersed, from structured to spread out. And this tendency gives rise to the sense that time moves forward, because the reverse processes, while not forbidden by the fundamental laws, are extraordinarily unlikely. It is not impossible for all the heat in a room to gather spontaneously into a single cup of coffee. But the number of ways for that to happen is so small compared to the number of ways for heat to spread out that it effectively never occurs. So we experience a one-way direction, not because the laws demand it, but because probability strongly favours it. And this idea extends far beyond coffee or messy rooms. It shapes everything we experience. Ice melts in a warm room, perfume diffuses through the air, a drop of ink spreads through water. In each case, the system moves toward a state where its components are more evenly distributed, more spread out, more mixed. And in doing so, it moves in a particular direction, a direction we interpret as forward in time, but there is another layer to this idea, one that connects it more closely to our experience. Because as entropy increases, something else tends to happen. Information becomes harder to track. In a highly ordered system, you can often describe things precisely. You know where objects are, you know how they are arranged, but as a system becomes more spread out, more mixed, more complex, that information becomes diluted, harder to recover, harder to reconstruct. And this has a direct connection to memory. You remember the past because information about it is still available, stored in your brain, in records, in the structure of the world around you. But as systems evolve, as entropy increases, information about the exact past becomes more difficult to reconstruct. It becomes dispersed, spread across many small interactions. So your experience aligns with the direction in which information is accessible. You move from a state where less information is available to one where more information has been recorded, and this gives the feeling of a forward flow. But again, it is important to notice. This direction is not built into the fundamental laws. It emerges from the statistics of large systems, from the overwhelming number of ways in which things can become more spread out compared to the very few ways in which they can become more ordered. So the arrow of time is not a force. It is not something pushing events forward. It is a pattern, a quiet tendency, arising from probability, from the structure of possible states, from the way systems naturally explore those possibilities. And this brings us one step closer to understanding why time feels the way it does. Because if the direction of time is linked to the spreading of energy and the dispersal of information, then perhaps the deeper origin of that direction lies in how systems interact, how they exchange energy, how they become connected, how they influence one another over time. As we continue, we will explore this idea further. We will see how the simple spreading of energy is connected to something even more subtle, the way information becomes shared across systems in ways that cannot be easily reversed, and in that process, we may begin to glimpse why the direction of time feels so deeply rooted in the fabric of reality itself. As the idea of entropy gently settles, with its quiet tendency for things to spread out, to become more mixed, more evenly distributed, there is a deeper layer we can begin to explore. Because when something spreads, when energy disperses, when a system becomes more complex, something else is happening at the same time. Information is being shared, not in the sense of messages or signals, but in the sense of connections, relationships, correlations between different parts of the system. To begin to feel this, imagine something simple: a drop of milk fall into a cup of black coffee. At first, the milk is separate, a small distinct region, clearly defined. But as it begins to mix, soft swirls appear, patterns forming and dissolving until eventually the milk is fully blended into the coffee. Now, imagine trying to reverse this process, to take that mixture and separate it back into pure milk and pure coffee. In principle, nothing in the fundamental laws forbids it. The motions of the molecules could, in theory, retrace their steps, but in practice, it never happens. And the reason is not simply that the milk has spread. It is that the information about its original state has been distributed, shared across countless tiny interactions, each molecule bumping into others, exchanging energy, influencing its neighbours. And through those interactions, the original structure becomes encoded, not in one place, but across the entire system. To reverse the process, you would need to gather all of that information perfectly from every interaction and use it to guide the system back. A task so precise, so delicate, that it becomes effectively impossible. And this is where we begin to see a deeper origin of irreversibility, not just in the spreading of energy, but in the spreading of information. As systems interact, they become more connected, more intertwined. Their states become linked in ways that cannot be easily undone. And this idea becomes even more interesting when we look at it through the lens of the quantum world, because at that level, these connections can become very strong. Systems can become deeply linked in ways that go beyond simple interaction. Their properties can become correlated, so that describing one part requires describing the whole. And as these connections grow, as more parts of the environment become involved, the information about the system becomes more widely distributed, less localized, less recoverable. You might imagine it like a story, whispered from one person to another. At first, the message is clear, but as it passes from person to person, small changes occur. Details are added, others are lost, and eventually, the original message becomes impossible to reconstruct exactly, not because it has vanished, but because it has been spread across many versions, many variations, many interactions. In a similar way, when a physical system interacts with its surroundings, its precise state becomes entangled with the environment, not in a way we can directly observe, but in a way that distributes information across many degrees of freedom, across many tiny components of the world. And once that information is spread, it becomes extraordinarily difficult to gather it back together. This process is sometimes described using a technical term, but we can simply think of it as the loss of reversibility, the point at which a system has interacted so much, shared so much information, that returning to its exact original state becomes effectively impossible. And this may be one of the deepest roots of the arrow of time, because as information spreads, as systems become more connected, the distinction between past and future becomes more defined. The past is the state where information was more concentrated, more accessible. The future is the state where information has become more distributed, more hidden, more difficult to reconstruct. So time appears to move forward in the direction in which information spreads, in the direction in which systems become more intertwined, more correlated, more complex. And this connects beautifully with what we've already seen. Entropy describes how systems move toward more probable states, more spread out configurations, and alongside that, information about the exact details of the past becomes harder to access. These two ideas, energy spreading and information dispersing, are deeply linked. They describe different aspects of the same underlying process, a process that gives rise to the feeling of irreversibility, of events unfolding in one direction, never quite retracing their steps, and yet, beneath all of this, the fundamental laws remain calm, reversible, unconcerned with direction. So, once again, we find ourselves in a quiet tension. At the deepest level, the universe may be timeless, symmetrical, without a preferred direction. But at the level we experience, where systems interact, where information spreads, a clear direction emerges, a flow, an arrow, and this arrow is not imposed from outside. It arises from within, from the structure of interactions, from the way information becomes shared and lost across the vast network of the universe. So perhaps the direction of time is not something fundamental, but something that grows, a pattern that emerges as systems interact, as relationships deepen, as information spreads. And if that is the case, then the question of whether time is real becomes more subtle. Because even if time is not fundamental, even if it arises from deeper processes, its effects are no less real. You still experience it. You still move from memory into anticipation, from what has been into what may come, and that experience remains grounded in the way the universe behaves at the level we inhabit. As we begin to move toward the final part of our journey, we can carry this understanding with us. That time may not be a simple, flowing entity, but a layered phenomenon, emerging from structure, from relationships, from the quiet spreading of energy and information, and from that foundation, we can begin to ask one final set of questions. If time emerges, did it have a beginning? And if it has direction, does it also have an end? As the idea of time as something that emerges, something shaped by relationships, by change, by the spreading of energy and information, begins to feel more familiar, a deeper question quietly appears. If time is not fundamental, if it arises from structure, then did it always exist? Or did it begin at some moment in the distant past? To explore this, we can turn to one of the most widely accepted ideas in modern cosmology. The idea that our universe, as we know it, began in a hot, dense state, often described as the Big Bang. But rather than imagining an explosion bursting outward into empty space, it may be more helpful to picture something softer, a state in which everything was compressed, not into a point in space, but into a condition where space itself and time itself were deeply intertwined and extremely dense. As the universe expanded, space stretched, structures formed, galaxies emerged, stars ignited, and over vast stretches of what we call time, complexity began to grow. But here is the subtle point. In this picture, time is not something that existed before the beginning, waiting for the universe to arrive. Time itself is part of the structure that began. So asking what happened before the beginning of time may not be a meaningful question. It is a little like asking what lies to the south of the South Pole. The question feels natural, because we are used to thinking in terms of directions, but at the South Pole, the concept of south simply ends. There is no further in that direction. In a similar way, if time began with the universe, then there may be no before in the usual sense, no earlier moment waiting beyond that boundary. Instead, the beginning of time may be more like an edge or a limit within the structure of reality. And yet, even this idea is not entirely settled, because when we look more closely at the earliest moments of the universe, we enter a domain where our current theories begin to blur. The physics we use to describe gravity and the physics we use to describe the quantum world do not yet fully agree in these extreme conditions. So while the Big Bang provides a powerful picture, it may not tell the whole story. There are other possibilities, softer, more speculative, but deeply intriguing. Some suggest that our universe may be just one region within a much larger structure, a vast collection of universes, each with its own properties, its own patterns, perhaps even its own version of time. In this view, what we call the beginning may simply be the beginning of our particular region, not the beginning of everything. Others imagine a cyclic universe, a gentle rhythm where expansion is followed by contraction, and then expansion again. Not a single beginning, but a series of beginnings, each emerging from the remnants of what came before. In such a picture, time may not have a single origin, but may extend through cycles, repeating in ways that are difficult to fully grasp. There are also ideas that suggest a kind of mirror, symmetry, where time extends in two directions from the Big Bang. In one direction, we experience time as moving forward, from past to future. In the other, a different region of the universe may experience its own direction, equally valid, but opposite to ours. These ideas are still being explored, still unfolding, still uncertain, but they all point towards something important, that the beginning of time may not be as simple as we imagine. It may not be a sharp boundary, a single moment, a clear starting point. It may be more like a transition, a region where our familiar concepts begin to lose their clarity. And this brings us back to the idea that time itself may not be fundamental. If time emerges from deeper structures, then asking when time began is a bit like asking when temperature began. Temperature appears when systems reach a certain level of complexity, when many particles interact, but it is not meaningful to ask for the temperature of a single isolated particle. In a similar way, time may appear when the universe reaches a certain kind of structure, when relationships form, when change becomes meaningful. So the beginning of time may not be a moment in time at all, but the emergence of the conditions that allow time to be defined, a quiet shift from a deeper, timeless description into a world where sequences, durations, and change become visible. And perhaps this is why the earliest moments of the universe feel so mysterious, because they lie at the boundary between two ways of describing reality, one where time is present and one where it has not yet fully taken shape. As we gently move toward the final part of our journey, there is one more question waiting for us. If time can begin, if it can emerge, then what happens at the other end? Does time come to an end, or does it continue, quietly, even when nothing else seems to change? As we come to the quiet edge of this journey, where ideas soften and begin to settle, there is one final question waiting gently in the distance. If time can emerge, if it may have had a beginning, then what happens at the other end? Does time ever come to an end? To begin to feel this, imagine the universe far into the future, not years from now, not even millions or billions of years, but stretches so vast that numbers lose their meaning. Stars have long since faded, galaxies have drifted apart, carried by the slow expansion of space. The night sky, once filled with light, has grown dark and still. In this distant future, the universe becomes quiet, not empty, but thin, diffuse, with energy spread so evenly that nothing stands out. This idea is often described as a kind of final balance, a state where everything is settled, where no further large changes occur, where temperature differences have smoothed out, where energy is no longer concentrated in ways that can drive activity. But we don't need the technical language. We can simply picture it as a place where everything has evened out. No strong contrasts, no gradients, no flows, just a gentle, uniform stillness. And in such a state, something curious happens. Time does not necessarily stop, but it becomes difficult to notice, because as we have seen, time is closely tied to change, to difference, to movement. When something changes, we can mark a before and an after. But when everything is the same, when nothing stands out, when no meaningful change occurs, there is nothing to anchor that distinction, no clear way to say, this moment is different from that one. So in a quiet sense, time loses its texture. It continues, but without structure, like a story that has reached its final page, where nothing more unfolds. This idea is sometimes called the heat death of the universe. But again, we can hold it gently. It is not a dramatic ending, not an explosion, not a collapse, but a slow fading, a soft settling into uniformity. There are other possibilities as well. Some suggest that the universe may one day reverse its expansion, gently drawing everything back together. Others imagine a future where expansion accelerates, pulling structures apart until even the smallest connections are stretched beyond recognition. Each of these possibilities paints a different picture, a quiet fading, a gentle collapse, or a gradual tearing apart. But in each case, time remains tied to change, and as the nature of change shifts, so too does the way time is experienced. There is also a more subtle idea, one that feels almost like a whisper at the edge of thought, even in a quiet, uniform universe. Small fluctuations may still occur, tiny patterns forming briefly before dissolving again. Among those patterns, it is possible, in principle, for something like a fleeting moment of awareness to arise, a brief configuration, complex enough to hold a sense of experience for just an instant, and then to fade, not as a lasting structure, but as a temporary pattern emerging from the quiet background. This idea is unusual, and we can hold it very lightly. It is simply one way of exploring how complexity and awareness might still appear, even in a universe that has largely settled. But rather than focusing on these distant possibilities, we can return to something closer, to the question that has been quietly unfolding throughout this journey. Is time real? We have seen that time does not behave like a flowing river in the equations that describe the universe. We have seen that different observers experience time differently, depending on motion and gravity. We have seen that the present moment is not universal, but local, shaped by perspective. We have seen that time may be part of a larger structure, where all moments coexist, and even more deeply, that time itself may emerge from relationships, from patterns, from the way systems interact and share information. And yet, despite all of this, time remains something we experience. You feel it, you remember, you anticipate, you live within a sequence of moments, each one connected to the next. So perhaps the question is not whether time is real or an illusion, but what kind of reality it has. It may be real, in the way that temperature is real, not fundamental but deeply meaningful. It may be emergent, arising from deeper structures, but no less present in the world we inhabit. It may have a direction, shaped by the way energy and information spread, and it may be layered, existing differently at different levels of description. At the deepest level, perhaps timeless, at the level of our experience, rich with flow, memory, and anticipation. So as you rest here, at the end of this exploration, you might gently hold all of these possibilities without needing to resolve them. Time may be a coordinate, a structure, a relationship, a pattern. It may be something we move through, or something that simply is, while we move within it. And perhaps it is all of these at once, depending on how we look. And so, we've reached the end of tonight's exploration. Whether your eyes are still open, or you're already drifting somewhere between waking and dreaming, thank you for being part of this quiet journey. If you'd like to return for more gentle wanderings through the ideas that shape our universe, you're always welcome here. Time has a way of slipping through our fingers, but here, in this quiet moment, There is nothing to chase, nothing to hold on to, just the soft unfolding of thought and the gentle hush of rest. Sleep peacefully, wherever and whenever you may be.